Welcome to module number 9, which is about securing user application and data access. It's a quick knowledge check with the right answers and explanation of the wrong answers as well. So let's start with the first question that we have. It says that which are the characteristics of an AWS identity and access management group? So there are two answers for this one. A user can belong to more than one group, and the other one is new users added to a group inherit the group permissions. The reason is that IAM allows a user to be in multiple groups and users automatically gain all permissions assigned to the groups as they join. Then let's explore the options which are not the right options. For example, the first one, a group can belong to another group. Nested groups are not allowed or not supported in IAM, so it cannot be an answer. The second option was permissions in a group policy always override permissions in a user policy. That's wrong because IAM merges all policies and explicit denies, overrides, allows. And then a group can have security credentials. That's wrong also because only users and roles can have credentials, not groups. Question number 2, it says that what is the advantage of using ABAC over RBAC? So the answer for this one is that ABAC will likely require fewer policies than RBAC. ABAC uses tags and attributes, allowing fewer and more flexible policies. Now, why we haven't selected the first one, which requires less testing than RBAC? That's wrong because ABAC can be complex to test due to dynamic attributes. We haven't selected the second option where it says that ABAC permission explicitly identify the resources that they protect. It's wrong because ABAC uses conditions, not explicit resources names. And we haven't selected the third option over here, which says ABAC permissions are more secure than RBAC. It depends on the configurations. ABAC isn't automatically more secure. Question 3 says that a developer is a member of AWS IAM group that has group policy attached to it. The group policy allows access to Amazon S3 and EC2 and denies access to ECS. The developer also has a user policy attached to allow access to ECS and Amazon CloudFront. Which option describes the user access? So the right answer in this one is to access to Amazon S3, Amazon EC2, and Amazon CloudFront, but no access to ECS. The reason is that IAM combines permissions but explicitly deny from the group and overrides allow from the user. Now let's see the other options in this one. If we'll select the first one where it says access to Amazon S3, EC2, and no access to ECS and Amazon CloudFront, it's incorrect because CloudFront is allowed in the user policy. Then if we look at the second one, access to Amazon S3, EC2, Amazon ECS, and Amazon CloudFront, that's wrong also because ECS is denied by the group policy. And we are not selecting the last option, which says that Amazon to ECS and CloudFront, but no access to S3 and EC2. S3 and EC2 are allowed, so they are not correct. Question number 4 says that what's the benefit of identity federation with the AWS cloud? So the right answer is that it enables the use of external identity provider to authenticate workforce users and give them access to AWS resources. Federation allows external authentication like AD or Google, while AWS controls authorization via roles. Now, we haven't selected the first option because it assigns roles to authenticated users to control their access to AWS resources. Reason is that role assignment happens after authentication, not the main benefit. Then if we look at the second option, it centralizes the storage and management of user identities inside of the AWS cloud. Federation keeps identity management outside AWS, so that's not correct as well. Then it says that it eliminates the need for defining permissions in AWS IAM to secure the access to AWS resources. IAM roles are still required for access control. Question number 5 says that which service enables identity federation for accessing the web application running in the AWS cloud? So The only option is Amazon Cognito. The reason is that Cognito enables identity federation for web and mobile apps, while external IDPs like Google, Facebook, or SAML providers. Now, we are not going for AWS KMS. The reason is that it manages the encryption keys, not identities. We are not going for WAF because it protects the web apps from attacks, not user authentication, and Cloud HSM is not the right answer since it provides hardware key storage, not identity federation. Question number 6 says that which service helps centrally manage billing, control, access, compliance, and security, and share resources across multiple AWS accounts? So the right answer is organizations. Organizations provide centralized management for billing, access control, compliance, and resource sharing across multiple AWS accounts. Now, we didn't select the system manager. The reason is that it manages the configuration and automation for resources, not multi-account billing or governance. We are not going for Cognito. The reason is that it's used for user authentication, not for account billing or management. And we are not going for IAM. The reason is that it manages user permissions within a single account, not across multiple accounts. Question number 7 says that a technology company has multiple production accounts grouped into production OUs in AWS organizations. The company wants to prevent all AWS IAM users in the production accounts from deleting AWS CloudTrail logs. How can system administrators enforce this restriction? So they can enforce it by creating a SCP and attach it to the production OU. SCP in AWS organizations set permission boundaries across accounts and can centrally deny actions like deleting CloudTrail logs, etc. Now, the other options of creating an IAM policy and attaching it to IAM user in the production account isn't right since it applies only to within an account and can be modified or can be bypassed. We are not selecting the second option, which says create an Amazon S3 bucket policy and associate with all the bucket containing AWS trail logs. It affects only one bucket, not scalable across the accounts. And we are not selecting the option of create a tag policy and attach it to the production account since it's used for enforcing tagging standards, not access restrictions. Question number 8 says that a developer is writing a client application that encrypts sensitive data using the data key before sending it to the server application. The client application sends the data key to the server application so that the server application can decrypt the sensitive information. The developer is concerned that the confidentiality of the sensitive data might be compromised if the data key is stolen. Which type of encryption should the developer use to fully protect the sensitive information? In this case, envelope information or the envelope encryption is the right option since it adds an extra protection layer by encrypting the data key itself with a master key, preventing exposure if the data key is stolen. Now, we are not going for server-side encryption. The reason is that it applies to the service level. For example, S3, not client level. We are not going for asymmetric encryption because it's used for small data or signing, not for protecting symmetric data keys. And we are not going for symmetric encryption since it protects data, doesn't secure the key itself. Question number 9 says that which function does the AWS KMS provide? So there are two things in this one: create symmetric and asymmetric keys and rotate the keys. So AWS KMS creates and manages cryptographic keys and handles automatic key rotation for enhanced security. Now, we didn't select store encrypted data since KMS manages the keys, not the data storage. We didn't select the second option, which says create AWS IAM access keys, since it's done by IAM and not KMS. And we are not selecting authenticate external users since it's handled by Cognito or SSO, not KMS. Finally, question number 10 says that which AWS service discovers and protects sensitive information stored in Amazon S3 in an AWS account. So the right option is Macie, because it uses machine learning to discover and protect sensitive information like personally identifiable information in S3 buckets. Amazon Detective isn't the right answer since it analyzes the security incidents, not sensitive data. We are not going for Audit Manager since it generates compliance reports, not data discovery. And we are not going for AWS RAM since it shares AWS resources between the accounts, not data protection. So that was our module number 9.